Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper question from May-June 2021, paper 41. And today's question is about simple harmonic motion. For part A, we need to state what is meant by simple harmonic motion. This is very basic question, but it is most frequently asked question in past papers. Almost every year, you will see they will ask you state what is meant by simple harmonic motion. So we need to be very clear about this one, how we can state simple harmonic motion. Sometimes this question has 2 marks, sometimes this question has 3 marks. Let's try to understand what is meant by simple harmonic motion. In order to understand simple harmonic motion, we need general equation. Let me write down here first of all the general equation for simple harmonic motion. General equation. A is equal to minus omega square x. A here is for acceleration, so we can write down A here is for acceleration. Omega is the angular frequency, so we can write down this is angular frequency. X is the displacement, so this is displacement. We also need to understand what is meaning of this negative sign. Omega for simple harmonic motion, omega is constant, so we can also write down this is constant. If omega is constant, then simply we can say A is directly proportional to minus x, negative x. As A is directly proportional to negative x, it means that as A increase, we can break down this one into 2 parts. We can write down A is directly proportional to x. It simply means that when the x is increasing, A is also increasing. The second point we can write down the meaning of negative sign. Sometimes in exam they will ask you what is significance of this minus sign. Significance. So that is very important question. 2 marks question, 1 mark question, they can ask you significance of minus sign. So this is very important point. You need to understand what is significance of this sign and what this sign is telling us. This sign is simply telling us the significance of negative sign. We can draw one small table. Let's say this is over A and let's say this is over X. Negative simply means that when X is negative, A is positive. And when X is positive, A is negative. Let's try to understand what this table is telling us now. According to this table, we have written when X is negative, A is positive. When X is positive, A is negative. What exactly it means? It simply means that acceleration is in opposite direction to displacement. Now we understand what is general equation for simple harmonic motion and how to state simple harmonic motion. We also understand what is significance of this negative sign. Let's try to state what is meant by simple harmonic motion, or simply we can say let's try to write down answer for this question. This question has 2 marks. In exam, if you write down acceleration of the body is directly proportional to its displacement, you will get 1 B mark. If you write down acceleration is in opposite direction to displacement, you will get second B mark, means you will get 2 marks, and the total marks for this question are 2 marks. If this question has 3 marks, then you also need to mention acceleration is always directed towards that fixed point. So you will get another B mark. So you will get 3 marks. But this question is only for 2 marks. If you have written this point and you have written this point, you will get 2 B marks. For part B, a spring mass system is given. As you can see in this figure 3.1, one oscillator is attached at this point. So this is our oscillator. So this one is oscillator. Then a spring is attached. This spring is attached with oscillator and trolley. After trolley, this one is the trolley, and after trolley there is another spring, and this spring is attached with trolley and it is also attached with the fixed point. So this is the fixed point. As you can see, it is given in the question, attached to a fixed point P, means it cannot move. For this question, it is also given the spring constant is 130 newtons per meter, and mass of the trolley is also given. The mass of the trolley is here. It is also given oscillations of the trolley are simple harmonic motion. We can also find the acceleration a of the trolley by this expression. So here is a and this is x and this is omega squared. So this part is omega squared. So a is equal to minus 2k by m times x. For this question, we need to calculate the frequency of oscillation of the trolley. X is the displacement of the trolley from its equilibrium position. In order to calculate the frequency, we need to compare this given equation with general equation of simple harmonic motion. So let me write down here general equation of simple harmonic motion. Now if you look at these two equations, we can simply find out that omega square here is equal to 2k by m. So simply we can write down here from here omega square, this is equal to 2k by m. 2k by m omega square, but we need to find the frequency. So we need to understand omega, this is also equal to 2 pi f. So this is, we can replace omega with 2 pi f because we need to find the frequency. So we can plug in value of omega. So omega is 2 pi f square. This is equal to 2k by m. We need to find out value of f. We can write down first of all, this is 4 pi square and this is f square. This is equal to 2k by m. We need value of frequency, so simply we can rearrange. So this is 2k divided by 4 pi square m, square root of this. Now simply you need to plug in values. K is given, the value of k is 130 newtons per meter. For pi square, we can plug in value of pi, we need to multiply with mass, but mass is given in grams. If we convert this one into kilograms, we need to divide by 1000, so this will be equal to 0.84 kg. We can write down here, this is 0.84 kg. We need to take the root of this. If we solve this, our value of frequency will be equal to 2.8 hertz. And that's the final answer. This is, we can write down here. Let's try to understand how marks are distributed for this question. If you have written omega square is equal to 2k over m, for this expression you will get first C1 mark. The second C1 mark is if you have written frequency in terms of k and m and you have plug in values, you will get the second C1 mark. And the third mark is for answer, means A mark, and that one you will get if you have got the correct answer, means your frequency is equal to 2.8 hertz, so you will get A mark. This is how marks are distributed, 2 C marks and 1 A mark for the correct answer. Even if your method is different but you got the correct answer, still you will get 3 marks for this question. For part C, it is given to us the amplitude is a maximum at the frequency calculated in B. In part B, we have calculated frequency that was equal to 2.8 hertz. Now we need to understand amplitude is maximum. When the amplitude is maximum, it simply means that system is absorbing the maximum possible energy. Simply we can write down the system is absorbing the maximum possible energy. So I will simply write down energy maximum is absorbing the maximum possible energy, and this will only happen if the driving frequency, in this case the frequency of oscillator, if it is equal to the natural frequency f0 of the system, then system is able to absorb the maximum possible energy. If this is happening, then amplitude also will be maximum. Question is asking us state the name of this phenomenon, and that phenomenon simply we call is resonance. So for this question you need to write down resonance. This question has only 1 mark and this is B mark, means you must write down here resonance because this marks is independent and it must be seen in your answer. If you simply write down resonance, you will get this B mark, you will get 1 mark. For part C2, it is given to us at any given frequency, amplitude of oscillation of the trolley is constant. We need to explain how this indicates that there are resistive forces opposing the motion of the trolley. First thing we need to understand is amplitude of the trolley, oscillations of the trolley is constant. It means that energy of trolley and spring system, that is constant, so energy of the system is constant, but oscillator is providing energy continuously to the system, but energy of the system is not changing. So what exactly it means? It simply means that energy has been transferred into any other form or work is done against resistive forces. That's the reason energy of the system is not changing. System is not absorbing energy, but energy supplied by oscillator is doing work against resistive forces. Let me explain to you how you can write a proper answer for this question. This is how you can write down a proper answer. First point, you need to write down oscillator supplies energy continuously. This is very important, and this is B mark. It must be in your answer, so this is very important. You have to mention that. Second part, energy of trolley is constant, so energy must be dissipated. This is also B mark, so this also has to be in your answer. If you write down these 2 points, you will get 2 marks.